On. Hello, good evening. How are you all? If you could take a seat, please. Settle down quietly as we celebrate the issues of a conference, a scholarly conference on climate change. My name is Professor Jerry McGill, and I am the chair of the conference committee. Tonight we have a wonderful platform for you, and to begin I would like to thank you all for coming. Thank you to the committee for planning this event. Thank you to President Doherty for leading us forward with an endowment to support this event going forward to the future. And we will begin with an invocation by Father French, who is the Vice President for Mission and Identity at the university.
Let us pray. All-powerful God, you are present in the whole universe and in the smallest of your creatures. You embrace with your tenderness all that exists. Pour out upon us the power of your love, that we may protect life and beauty. Fill us with peace, that we may live as brothers and sisters, harming no one. O God of the poor, help us to rescue the abandoned and the forgotten of this earth, so precious in your eyes. Bring healing to our lives, that we may protect the world and not prey on it, that we may sow beauty, not pollution and destruction. Touch the hearts of those who look only for gain at the expense of the poor and the earth. Teach us to discover the worth of each thing, to be filled with awe and contemplation, to recognize that we are profoundly united with every creature as we journey towards your infinite light. We thank you for being with us each day. Encourage us, we pray, in our struggle for justice and for love and for peace. We echo the thoughts and the prayers of Pope Francis as we begin this inaugural presidential conference on the integrity of creation. We ask God's blessing on our presenters and participants, both here at Duquesne University of the Holy Spirit and around the world. And we pray all of this through the Spirit, who always gives life. Amen.
You may be very relieved to know that to speak on this stage tonight you do not need to have a Scottish accent. As I mentioned, we are very blessed that our President Doherty has arranged an endowment to support this conference forever into the future. Let me introduce President Doherty.
Thank you, Professor McGill. I'm ashamed I don't have a Scottish accent, but I can claim at least one forebear who did. So I have a lineage that dates back to somewhere near Loch Lomond. Thank you all for being here. As has been mentioned already, our formal name is Duquesne University of the Holy Spirit, and our religious sponsors are the Spiritan Congregation, a worldwide missionary group committed to teaching and to working with those who are marginalized by society, those who are poor, those who are facing injustice. They go by a very brief summary of what they stand for, and it is justice, peace, and the integrity of creation. Now, even though we may differ on the meanings of the words, most people understand the significance of justice, they understand the significance of peace, but there's a great deal of confusion about the nature of the issue of the integrity of creation. And so we have created this conference to generate a dialogue, a conversation, around the question of respect for the integrity of creation. And it means, as the Pope made clear in his recent visit, not simply respect for nature, although it means that in a profound way, but it also means that concern for the most vulnerable, who are always hurt first when something runs amiss with what happens in creation. Whether it's the rising of the seas, whether it's spending life living near or in piles of garbage, and whether it's living with deforestation in their own nations. So in accordance with that, and with our own general mission as a Spiritan University, we have established funding for this as an annual conference. So it will happen not just today, it will happen next year, it will happen every year. And we thank you for being part of our inaugural conversation, and we hope you will come back again and again to help us advance this as an academic conversation, but one which will have a very important impact on the future of our understanding of our respect for the integrity of creation and its impact on other human beings. Thank you.
Well, it's very difficult to be a Scotsman and not talk about money. So, those of you who know that parking is expensive, it's even more expensive when there's sports stadium activities in our neighbourhood. However, happily, Scots' frugality won the day, and we were able to get a reduced parking rate of $5 for you, as opposed to the many other dollars you would be paying. So the way you get that is take your parking ticket, do not use the parking machines in the Forbes garage, just drive out to the exit with your parking ticket and say to the attendant, you were at the climate change conference, and they will charge you $5. So you've saved some money. I was thinking of having a little donation tin for the differential, but I thought maybe we shouldn't have a collection. There are many people to thank in a conference like this. Glory Smith, would you mind standing, who has enabled us to get this done superbly. I have a wonderful array of students, graduate students, who are working with us over the next 3 days, and thanks to them all, their dedication and inspiration is wonderful. If you can come back over the next full day and a half through Friday lunch, you'd be very welcome. It's going to be a really exciting conference with great speakers and great interaction. Fortunately, we're also very blessed with the Spiritans, not just because of them sponsoring this university and their the Spiritan mission being the identity of our conference, but we've got some very nice Spiritans from Rome and from Ireland. So Father John and Jude, would you mind standing to let us identify you? Thank you for coming a long way. We have, I'm not going to ask anyone else to stand, so you don't have to be too embarrassed, but we have an abundance of great talent here with our speakers. But before that, I want to give a special welcome to two of our guests who have graced us with their presence. We have Richard Piacentini, who is the Executive Director of the Phipps Conservatory and Botanical Garden. And we also have Mr. Larry Schweiger, who is CEO of Penn Future. And those of you who know the name Al Gore, he's the chair of Al Gore's Climate Initiative. So we're very blessed to have both of them with us tonight. Thank you for joining us, gentlemen. Now we have an amazing Nobel laureate to lead us forward, and I would ask Phil Reeder, who is Dean of the Bayer School of Environmental, Natural and Environmental Sciences, to come forward and introduce our speaker. Phil? Oh no, is it Alan? Alan, sorry, that's Phil's tomorrow. Is Alan here? Alan, sorry, that's a mistake on my part. Alan Seidler is our Vice President for Research at the university. He's a wonderful colleague with whom I work a lot, so forgetting his name tonight is kind of, a slip. So he'll forgive me. He owes me a lunch anyway, so that'll be all right. Alan, please come up and introduce our speaker. Thank you.
I can honestly say I am not Dean Reeder. I'm much too short. But it gives me great pleasure to introduce our keynote speaker for tonight, who is has had an amazing academic and scholarly record, as well as providing a fair amount of influence to some of the political decision-making process. Dr. Richard Alley is the Evan Pugh Professor in the Department of Geosciences and Earth and Environmental Systems Institute at Penn State University. Now, being a good Ohioan as I wasn't entirely sure, should I call it Penn State University or should I call it the Pennsylvania State University? But I think we all know it as Penn State. He's ranged from Antarctica to Greenland to help learn the history of the Earth's climate. Rather, the great ice sheets will fall into the ocean and possibly flood our coasts. With over 250 scientific publications, Dr. Alley has been asked to provide advice to the highest levels of government, President's Science Advisor, and an advisor to committees of both the Senate and the House of Representatives, as well as to individual members of both bodies. He's been recognized with numerous awards, notably his election to the United States National Academy of Sciences and the Royal Society. He is also a member of the Intergovernmental Panel on Climate Change, which shared the Nobel Peace Prize with Al Gore in 2007. As an advocate for his field, Dr. Alley has hosted recent PBS miniseries, specifically Earth, the Operator's Manual, and this is from him, not from me, and he has been compared to a cross between Woody Allen and Carl Sagan, particularly for his enthusiastic efforts to communicate the excitement and importance of the science. His popular account of climate change and ice cores, The 2 Mile Time Machine, was Phi Beta Kappa Science Book of the Year in 2001. And again, this is from his comments. He is happily married with 2 grown daughters, 2 stay-at-home cats, a bicycle, and a pair of soccer cleats. It gives me a great honor and it's a great privilege to welcome Dr. Richard Alley to give his talk tonight entitled Gold and the Golden Rule, Economic and Ethical Opportunities on Energy and the Environment. Please, with me, welcome Dr. Alley.
Oh, thank you so much, Mr. President. Spiritans, to you for coming. It is just truly a pleasure to be here. I am sincerely hoping that we will be able to move forward with my slides here, so if they can appear fairly shortly, that would be nice. And if not, we'll see what we can do to pull this together in just a minute. But it is indeed, yeah, so we will get this in a moment. I will get started in the meantime when a wiser head than mine is about to help here. So we'll see what we can do. But it is a pleasure to be here to try to deal with peace, justice, and the integrity of creation is sort of a large thing and a large remit, and I can't possibly deal with all of it for what it's worth. But I'm going to try to do a little piece of it for you and walk you through. Some thanks to the President has endowed this, to your Scottish accents, Glory Smith for making this work, and to so many other nice people who have made me feel so at home so fast. So I have had the great good fortune of studying the big ice sheets, so I'm going to take you to Greenland first. And if you've never had the chance to go, I heartily recommend it. It's a beautiful place. Here are some musk oxen trampling over a Greenland forest, for what it's worth. And in these days, I answer email and give talks, and students go, but there was a day that I used to go to Greenland, and we often did it on these big planes, and we go up there in the middle, and it's 2 miles high, and you're on 2 miles of ice, and it gets up to 10 below on the hottest day of summer. If you ever do get the chance to go, you will notice there on the left side of the picture, there's some newspapers. At this point, they were a month old. you will notice on the right that in fact they were perfectly functional. This is labeled a good day in Greenland. This is a bad day in Greenland. If you had to go, you better shovel in a hurry. Okay, and we went up there to do ice cores. And so here is Kurt Cuffey and Wanda Kapsner studying ice cores in our secret undersnow laboratory. For those of you who are deans or provosts or presidents, in this particular place, if your lab wasn't big enough, you got a chainsaw and you hacked out a chunk of wall and it was bigger. So we took these ice cores and we bring them up, and I wrote the book. We have a very long story of how we turn ice core into wiggly lines. And these are wiggly lines that you see up there. And so these wiggly lines have a history of temperature and snowfall, and this happens to be the last 10,000 years of temperature in Greenland. Now, this is not the whole world, this is Greenland, but it looks a whole lot like anything around the North Atlantic. And this 10,000 years ago is on your left, today is on your right. And this 10,000 years, there's a broad arch there that is linked to features of Earth's orbit that change very slowly. The Earth sort of nods and back and it wiggles. And this changes how much sun gets to the far north. And this gets more and this gets less. And so this is, and riding on the back of that are wiggles. And those wiggles are caused by the sun changing its brightness. They are caused by big volcanoes blocking the sun. They are caused by changes in ocean currents and some other things. And there's sort of a degree in Greenland. And the most recent ones have names. Because those little 1 degree sort of wiggles were big enough that they affected people living there. And so you'll see the medieval warm period and the little ice age sitting there. Now, if you get to go to Greenland, if you're fortunate, you'll get to go to the cathedral at Valsey. So this is South Greenland now, and that little Google doogie there is pointing at the cathedral at Valsey. And this is one of the more fantastic places I have ever been in my life. It's this beautiful church. It's built on the side of the fjord in the 1300s. The last known use is on September 14, 1408. A party had sailed over from Iceland, and they witnessed a wedding, and when they got back, they wrote about it. And very shortly thereafter, this was abandoned. Okay, and then, since 1410 or so, this has just been sitting there on the side of the fjord. Now, you will remember that the world is made of a big band full of people along the middle that is a little bit hot for comfort, and a little cap with not many people that is a little cold for comfort. And this is part of that little not many people cold part. And it was settled in the medieval warm period when Greenland has always been icy and Iceland has always been green. Greenland was an advertising campaign. But anyway, it was easier to be a Greenlander having a Norwegian European farming community in the medieval warm period than the little ice age. And the ocean was freezing, and the bishop couldn't get over from Norway or from Iceland to bless the rites. And at some point, the people said, screw it, we're out of here, and they became environmental refugees. And so that little wiggle that you see there was enough to affect people living on the edge with high confidence. Now, you'll notice that I have whited out the left-hand side. This for very good reason, because if that wiggle is enough to affect people, that's interesting. Okay? Now that one jump there in Greenland is about 10 Celsius or 18 Fahrenheit in about 10 years. And it happened. It's linked to features of Earth's ocean circulation and sea ice and a bunch of other things, and I can tell you the story of that someday. It was a natural thing. The whole world's climate changed, but it changed different ways in different places. So it's a very interesting thing. It's real. There's no serious debate about that. And if we take this and we look farther back in time, the previous slide you'll notice is boxed on the end, and you will notice that for a long time, climate was sort of crazy. And then sort of 10,000 years ago, it settled down a little. And what happened then almost everywhere around the world, agriculture starts. So we have hunter-gatherers running through all that craziness, and sort of as soon as it got boring enough, agriculture started. So let's zoom in again on that edge there, and we'll blow it up for you. And crazy on the left, more boring on the right, and agriculture starts at the line. Now, be very clear. I will later tell you CO2 is a greenhouse gas. CO2 is a greenhouse gas. If you want to argue about that, you should go look in a mirror for a long time. Okay? I'm going to tell you a story that has people in it right now. I will guarantee you that I am oversimplifying this, because we can never tell stories with people in it and get them into a little box. It's real easy to tell the story, but be very clear that what's going on here is more than what I'm going to tell you. But I believe what I will tell you is accurate. Okay? So with that, let's ask this question. What is life like for sort of a healthy adult in good times on the left, hunter-gatherer, and on the right, agriculture? So here we have it, a healthy adult in good times. What is life like? And, so what do you do if you're a hunter-gatherer? You kick on down the road, life's pretty good, you pick a few leaves, you have some fruit, you don't like it here, you go there. What do you do if you're a farmer? You spend the summer scratching the dirt with a stick. Okay, this is, anyone who is not hoed may not know this, but hoeing is actually hard work. And so there's a change there. Now, people keep trying to get us to eat what our hunter-gatherer ancestors ate. A little bit of a whole bunch of things with lots of fruits and veggies. What do you eat if you're a farmer? Maybe a little milk, maybe a little meat, a lot of ground up grain, You swapped the whole food pyramid for gruel. Now, this one may be the biggest one. If you were a hunter-gatherer and you get a bug, you go behind the tree and you leave it there, and you come back in a year and it's dead. If you're an early farmer, if you're sophisticated, you're pooping in somebody else's water, and if you're not sophisticated, you're pooping in your own water. And you literally, you're living there with it. You got to go to the bath. You don't have modern sewers when you start this. And a lot of our history is figuring out how to deal with that. But be very, very clear. You are now living with your diseases. And we see this very, very close. So what do you get? A healthy person is a hunter-gatherer. They were tall, they were strong, they had good teeth, they had good bones, right? What happens when you switch to farming? It's not as pretty a picture. And yet, everywhere around the world, in South America, in Central America, in Asia, in the Middle East, everywhere around the world, as soon as they could do it, they did. They traded everything on the left for everything on the right. Now, why in heaven's name would you do that? And the odds are pretty good that they did it because the world was full. It was overpopulated for the technologies they had at the time. If you had a bad year and there wasn't enough food in your valley, you couldn't go to the next valley over to hunt and gather because the big rock tribe lived there. And they had big rocks and they wanted your valley. And it's fairly clear that what happened is when you had a drought, your kids and your grandparents died. And there really wasn't a way out of this. There's not enough food. And what do you do? And in fact, probably the world was overpopulated. Our ancestors, they came into the Americas, and there are mastodons and mammoths. There's stakes on the hoof everywhere, and they contribute to extinctions. So a few million, probably, people were lowering the carrying capacity of the planet. It was full. It was overfull. Now, in fact, if you count carefully, there are a few billion of us now. And we hope we're not lowering the carrying capacity too much and it's not overfull. But be very clear, without our know-how, the stuff we've built and the things we've learned how to do and our ability to get along with each other, without our know-how, of the next 1,000 people you meet, maybe one survives. Nobody gets out of this room. Okay? Knowledge is not optional. Education is not optional. Medicine is not optional. Okay? Okay? We've gone from drinking diseases and eating gruel to what we have now with the healthcare and food and the water and you know, with 1,000 times more people. And what we've achieved is phenomenal. It's truly amazing. But we don't always remember that, okay? Now, my piece of this is science. That's a small piece of it, and I will emphasize that in a minute. But it's a fascinating thing. I have my cell phone here. It's turned off. If you go into a 5th grade class and say, what is this? They'll say it's a cell phone. And if they're up close, they'll say, well, it's sort of a little old cell phone, isn't it? You're not very cool, are you? Right? But then you say, what's it made of? Cell phone parts? What's it made of? It's that much sand for the glass and the silicon, and it's that much oil for the plastic and the right rocks. And science and engineering and design and marketing. Just a little bit of sand, a little bit of the right rocks, and a little bit of oil and know-how. Okay? Now, I guarantee you, if you actually took the sand, the oil, and the right rocks, and you gave them to certain groups of people, the Senate, right? And you said, turn these into a cell phone, okay? You're going to wait a long time, all right? But be equally clear that there are people in the world that will take their cell phone and they will send me a message that says, you are evil, you scientists don't know what you're talking about, you should shut up and get out of the way because science has no more insight to how the world works than anything else. And they will do it on a cell phone. Okay, right? So we have a fascinating communications issue to deal with here, right? And so be very clear. Us being here, there are things which are not optional. And I think the biggest one is getting along with our neighbors, okay? But cleaning up after ourselves, growing and building and learning and teaching and learning how to do them better are not optional. They are absolutely essential to our survival. And be very clear, science and engineering and agriculture and medicine are the best things we have ever come up with to keep us fed and clothed and housed and healed so that we can think about the big issues that so many of you in this room think about. But if we want to, you know, it's hard to hear the word of the Lord when your stomach is growling. And that is really important. Okay? Right. So ultimately, this is about sustainability. You will find lots and lots and lots of academic definitions of sustainability. I will use mine as living so our children can live well, and their children and their children. Okay, the UN has looked at sustainability. They say energy and agriculture are the biggest. We should keep an eye on phosphorus for fertilizer. Water is a big deal. There's a bunch of others. But the truth is a lot of the agriculture issues come into energy as well. And so I'm going to go to energy as the biggest technical issue in gaining sustainability. As I said, I don't think that it's the biggest issue. I think that's getting along with each other. But the biggest technical issue in sustainability is probably finding a sustainable energy system. So I'm going to walk you through that. We had a really nice dinner tonight, and I ate the cake. Okay, so my 2,000 calories per day may be a little low today. But at any rate, they calculate our diet on 2,000 calories. But that cake was refrigerated, and it was made of things that were cooked, that were made of things that were grown on a farm with a tractor and were trucked to us. We live in a room which is lighted, that is climate controlled. If you take all the energy used in the U.S. economy and divide it by the number of people in the U.S. and convert it to these archaic units, it is 240,000 calories per person per day. What we can do for ourselves is 2,000. What is being done for us is 240,000. It is like each one of us has more than 100 energy sources to do our business. And 85% of that is fossil fuels. Okay? And be very clear, we love it. If I keeled over right now, you would have an ambulance here, you'd take me to one of the good hospitals here, you'd have a heart-lung machine to keep me going. We love this. Don't kid anybody. And it's a lot of why there's so many of us. All right? But we have a long history, which I'm going to walk you through a little bit of it, of burning through something far faster than nature makes more of it, and then hitting a crisis and having all kinds of problems before we get the next answer. And this one is no different. Okay? So I come to you from central Pennsylvania. My university is Penn State, University Park. It is next to the town of State College. State College is a suburb of Penn State. When University Park was founded, when Penn State was founded, there was no State College. It grew up later. What there was an iron furnace. And Penn State is founded up the hill from the iron furnace. And the east was built to Juniata iron. And when the iron furnace was in blast, it looked like this one from the National Park Service. It was turning red dirt, flux from limestone, and charcoal into iron that you could use for useful things. And there were 100-some people taking care of it. And there was a whole town that was doing this. And the thing is fueled by charcoal. And the charcoal making is this fascinating, horrible history where they'd make these giant piles of logs, and then they'd bury them in dirt, and then they'd get their picture taken, but then they'd get off and they'd start burning it with restricted airflow. And if the dirt broke and they had to get back on top, if you fell through, you're going to die. But, you know, it was not a necessarily nice thing. And it did this to the forests. A furnace and the people taking care of it took sort of a square mile of trees per year. Furnace and blast, more than half a square mile of trees per year for the charcoal, and then all the people are cooking and heating and building houses. So think a square mile of trees per year per furnace. If you go on a Gazetteer of Pennsylvania and you ask how many place names in Pennsylvania still say furnace, it is everything on the left. Now the ones on the right are forges, Valley Forge and other, where they took the pig iron and turned it into useful things, another square mile of trees per year. Every one of those lines, plus a whole bunch of things that have disappeared into the mists of antiquity, is a square mile of trees per year when it's working. And so the first forester of the Commonwealth was Rothrock. He had once been a professor at Penn State, and he wrote about the Great Pennsylvania Desert. Now, in fact, it wasn't a desert, but it had essentially no trees in the entire state. We have 1 million deer now. There were virtually none. We have elk now because we re-imported them from the Rockies. We chase off the elk, we chase off the bison, we're the Nittany lions, right? There's no Nittany lions. There wasn't a tree to do it behind. And it wasn't just us. Across the world, we cut trees far, in the old world, in the new, and all up and down the coast, we cut trees far, far faster than they grew back. And eventually the iron moved out here to take advantage of coking coal rather than being up where we were because the trees ran out. If you've ever tried to read by firelight, it's not easy. Poor people used to use camphene. It was a mix of alcohol and turpentine. It burned cleanly, but it tended to make fires and blow up. And there's these horrible old stories. You can pull out the old New York Times, and the Methodist minister and his wife go off to visit the parishioners, and they leave the daughters at home, and the daughters try to refill the lamp, and they burn themselves to death. And rich people used to burn whales, or whale oil. And they would send Yankee seamen out to scour the world ocean for whales to cook down to oil to bring home and burn. And it was nice light, and it was clean, and it didn't stink, and it didn't blow up. And so here is the history of whale oil production in the Yankee fleet from 1800 to 1880. This is a more complicated plot than it looks. There's a civil war in there when they sank a bunch of ships off of Charleston Harbor to try to blockade it. There's the fleet getting trapped in the sea ice off of Alaska and the insurance rates going through the roof. But what was the fleet doing in the sea ice off of Alaska? They couldn't find any whales closer to home that they could catch. They had cleaned them out almost completely. You'll notice the price on top. The bottom there was $7 a gallon in modern money. Once they hit peak whale oil, it went up to 23. And right after that, you see the green line, which is the first modern oil well. They went right up the road here. Oil was leaking out of the ground. Colonel Drake said, wow, if oil is leaking out of the ground, maybe there's oil in the ground, and drilled a hole into it. And, now be very clear. When the oil runs out, we're not going back. This is 100 years of Yankee whaling. At the peak, there were 10,000 sailors on ships out of New England scouring the world ocean for whales. And sort of from 5 or 10 years ago, they collected a week of oil imports. Not even total use. Okay? What we use now is just flabbergastingly amazing. Now, this is an editorial cartoon. It was published in the magazine Vanity Fair in 1861. If you can't read it from the back, it says it's the grand ball given by the whales in honor of the discovery of the oil wells in Pennsylvania. And it says, the oil wells of our native land, may they never secede, right? This is right before the Civil War. Oil's well that ends well, right? We have whales and trees because we switched to burning fossil algae and fossil trees. And it's about that simple. And when we think about caring for creation and the integrity of creation, and we think about a sustainable energy future, we have to remember that. We have to remember the good that we have gotten from the fossil fuels. But we can't keep doing this. The fossil fuels accumulated over a few 100 million years. We are burning them over a few 100 years. We are burning them 1,000,000 times faster than nature saved them for us. It is not a question, do we do sustainables or do we do fossil fuels? We have to do sustainables. It's only a question of when. All right? And the numbers, what we put out to the curb in America for the trash collector is a little less than 1,000 pounds per person per year. The CO2 that comes from our fossil fuel burning is 40,000 pounds per person per year, maybe a hair under, but basically it's 40. 1,000 that we put out for the trash collector, 40,000 that we put in the air. If all that CO2 were condensed to the density of water and put on the roads, it'd be 1 inch deep on every road in America in a year. In 10 years, there would be no joggers in America. Okay? We'd all be cross-country skiers. And the easy stuff is gone. Right? A few of you are old enough to remember when there was once a situation comedy on our energy system. Right? It was a story about a man named Jed. It was a poor mountaineer, and he barely kept his family fed, and one day he was shooting at some food, and up through the ground come a bubbling crude oil, that is. Right? And they could do that because the oil leaked out of the ground. What are they doing out in the Gulf? What are they doing fracking? The easy stuff's all gone already. But there's a lot of hard-to-get-to stuff. Okay? Now, when you burn that 40,000 pounds of CO2 per person per year, almost that much, it's going in the air. And something goes in the ocean to make it more acidic. But we have known for well over a century that that has a warming influence. This was really worked out by the Air Force right after World War II, and they weren't doing global warming. One of the jobs of the Air Force after World War II was make sure bad guys with bombers didn't fly over our cities and flatten them. One of the tools they chose was a heat-seeking missile. The hot exhaust of the enemy bomber can be followed by a sensor because of the infrared radiation, and you can fly up their tailpipe and make sure they don't get to your city. But if you put the wrong sensor on, you can't see the hot exhaust because CO2 or water vapor soaks it up and spreads it through all the air. This is something that's well known. It's observed every day. There's no serious question about it. And if you went out today, even on this gray day, there was heat from the sun warming the Earth, and the Earth was sending energy back to space, and there was more energy going up from the sun-warmed Earth than coming down from enemy bombers. That little plot down in the corner is satellite data, looking down at the Earth and actually watching over time the Earth sending energy to space, and this is energy that is not getting out because CO2 is blocking it. And if there were more CO2, it could block more. Measured, and more can do more. Okay? So you get to the point of, do you believe in global warming? It's sort of like, do you believe in gravity? We don't know how to avoid it. We're putting CO2 up. CO2 absorbs. We observe that. It's very clear. Okay? There isn't another side. This is the best we have. You can't go, this is one thing that's just hugely wrong, is people say, let's hear the other side. No, there is not another side. There are people who think I should be scarier, people who think I should not be as scary, but we're putting CO2 up and that's absorbing radiation and that has a warming influence. It's just physics. We can't get out of it. We argue about this. We're learning more. You send us students, we'll welcome them and do research. But the basic picture has not changed in a long time, and it is very, very, very unlikely to change. Okay. Now, I wrote a book on this. I served with the UN on this. I served the National Academy on this. I've helped the Royal Society on this a little bit. I have the story. I wrote a MOOC on this. If you want it someday, yes, it is getting warmer. Yes. Yes, it has the pattern that we expect from our influence plus the other natural things. How much of it is natural? Nature has tried to cool it off. The best estimate is that we have caused more warming than we've seen because nature has dimmed the sun a little bit. Nature has blocked the sun a little bit with volcanoes. We have cut dark forests and replaced them with more effective grasslands. There's a lot of cooling influences, and yet it's gotten warmer. So probably how much of the warming is natural? Well, how much of it is us is more than 100%. Okay? And the scientific understanding is very clear. It's working very well, and it says if we keep doing this, the changes are going to get a lot bigger. Okay? So what does that mean? Nobody cares about global average surface temperature. Nobody cares about global warming. We care what does it mean for the integrity of creation? What does it mean for living things, us and other ones? I've got a whole list of things up there that might matter. Grain belt drying and crop heat stress I'm going to poke at a little bit. Sea level rise is what I work on. It doesn't mean you have to get malaria, but you lose one line of defense. If you're counting on saving unique ecosystems in your national park, but the climate changed and they need to move and we're in the way, what do you do? Right? Very important, and I will come back to this, the costs rise faster than the temperature does. And that's one that we'll need to come back to. But here's one first. These are complicated plots. Pick one of them. The one on the right for corn may be a good one. And what you see here, on the bottom is temperature. And on the top is yield. How much corn do you get when you grow it? Okay. And what you see is that there's an optimum temperature. And if it gets colder than that, it doesn't grow well. And if it gets warmer than that, it also doesn't grow well. And you'll see actually a fairly large fall off in yield there as you go to the warmer things. What you'll also see at the bottom is the temperature at which we grow our corn in the U.S. And you'll see that a whole lot of our corn is grown more or less near the optimum. Make it colder and the corn won't like it. Make it warmer and the corn won't like it. Now that's the U.S. though, and remember we have a lot of things that are closer to the pole than many countries do. This is a different view of the same thing. So each dot is a country, and we have corn on your left, that's rice on the right. Look at the corn one for now. Each dot is a country, and it's plotted by temperature on the bottom and by yield on the y-axis. And a big dot means they grow a lot of corn, so that really, really big dot is us. And you'll notice that there's a gray band. A gray band is the optimum temperature based on laboratory and field studies in controlled conditions in universities. And we grow a huge amount of corn with a big yield at just about the perfect temperature. And what you'll notice is most of the corn-producing countries of the earth are warmer than us. And they're warmer than the optimum. And you'll notice that as you go warmer, the yield go down. Now that is not just climate. They tend to be poor, they tend to have less fertilizer. There's a lot of things in this plot as well as climate, but climate is in there. And a whole lot of our food is grown at temperatures above what it likes. Okay, now this one, if we keep burning fossil fuels on the trajectory we're now on, red is, by late in this century, the average summer will be hotter than the hottest summer we've ever seen with more than 90% confidence. Okay? The average summer hotter than the hottest we've seen with high confidence. And you'll notice the others go down to 50%, that the average summer is hotter than the hottest one we've seen. We're growing a lot of food at temperatures above where it likes. And the hottest summer it's weathered so far will be below average if we continue on this trajectory. this comes to this one, and this really comes to a lot of the discussions of the next couple of days. People, this is emissions of CO2 per person per year, basically. And so red is emitting a lot, and blue is not emitting much. This is who is really vulnerable, who has their food already too warm, who doesn't have the bulldozers and air conditioners to deal with it. And red is highly vulnerable, and blue is not so vulnerable. People with winter and bulldozers and air conditioners, winter, you know, it gets a little warmer, you just lose some winter. And you got a bulldozer, you can make a wall against the sea, and you got an air conditioner, you can work in the summer. And so the wealthy people don't get hurt very much up where we are. But if you don't have winter bulldozer and air conditioners, making it hotter is not a good thing, and that's the red on there. And so if you put these two plots together, on top red is changing the climate, on bottom is red is suffering from the changing climate. And so what you get is that those who contribute the least are most impacted. Okay? And I will venture just a little bit here. If you heard Pope Francis, he said, it seems clear to me also that climate change is a problem which can no longer be left to a future generation. And I'm a Methodist. We attend St. Paul's in downtown State College, and I'm reasonably confident that my pastors are not happy with this particular plot, and I'm reasonably confident that Pope Francis is not happy with this particular plot. Okay, so there's a real golden rule issue here. All right, now, a few other things, right? 2014, a bunch of distinguished retired U.S. generals and admirals said, we are not going to tell you that climate change caused civil war, but it is a stressor. There is a dashed line, they didn't use those terms, but that's what they said. There's a dashed line between climate change and bad things that are happening in many places. While climate change alone did not cause the conflict, it certainly added environmental stressors. And they have called out, you know, bad things that have happened and are happening in many places as being linked to food shortages, which are in part exacerbated by climate change. So this paper came out this year in Pursuit of the National Academy of Science. If we zoom in here, drought contributed to the conflict in Syria. Human causes made that drought more likely. Did we cause it? We made it more likely, and it happened. We loaded the dice that something would happen. A big drought hit. The drought spiked food prices. A fragile situation crumbled, and you see a lot of suffering. This is a recent paper. It's one paper, but it's fairly consistent with a bunch of others of if we keep burning, by late in this century, the green places are actually expected to have slightly less drought. The reds and yellows and purples are expected to have more drought. You'll notice that the green places tend to be where there aren't a lot of people right now, and the reds and yellows and orange tend to be where there are a lot of people right now. And if we zoom in, humans have probably contributed. They've made it more likely that we had the drought in Syria. And look at the projection for what will happen if we keep burning by late in this century. Okay. That's not, I don't think farmers there will smile at that. Okay. This is for the U.S. Now brown is more drought. So, so you'll notice who gets more drought and who gets less drought. And if you look where most people live, and then you look south towards Mexico, yeah. Okay. Back to this. Costs rise faster than temperature. The first degree of warming didn't cause, I mean, it's contributed in a lot of things, but so far it hasn't cost a lot, but we've already had it, or almost all of it. We're used to variability. We've dealt with it before, but now we've warmed almost a degree. And we're committed to the second one with pretty high confidence, because there's momentum in the climate system, there's momentum in the economic system. And so we're arguing now about 3, 4, and 5. Now these are Celsius, global averaged, multiplied by 1.8 to get Fahrenheit, and the land warms more than the ocean does. And so basically almost all people are getting a lot more than those numbers, to be honest. And as we move outside of experience, if it warms up where you live, you can borrow wisdom and crops from people in hotter places. But when you change large areas to be hotter than anything now on the planet, where do you go for those crops and that wisdom? And so as you get a bigger climate change, the impacts build up faster than that does. Okay. This is important as well, I think. This is science. It is not revealed truth. There are real uncertainties in it, and that is not a good thing. Because we basically all know that building is harder than breaking. CO2 actually makes plants grow better. And we've included that in our assessments for a very long time, but not by a lot. And the reason is they depend on so much else. But if it gets too hot, you can kill your plants. And if it gets too cold, you could kill them. And if it gets too wet, and if it gets too dry, and too little fertilizer doesn't help. My dad used to kill my mom's flowers by over-fertilizing, right? And you need your pollinators at the right time and the right pollinators, and you don't need the invasive bugs. And so the uncertainties include a whole lot of bad things that could kill a lot of plants. And across a huge number of things, my sea level work and that of our community, we get the same answer. There's a best estimate. Things may be a little better than that. They might. They may be a little worse than that. They may be a lot worse than that. But we don't see how to get a lot better, because essentially CO2 is a big hammer, and it can't build the Garden of Eden, but it might break things we care about. So in some very real sense, the less you trust me, the more nervous you should be about 40,000 pounds per year of a radiatively active gas being put in the air by us. And at the bottom, I've got a note. We might trigger a collapse of an ice sheet or loss of the rainforest or some other scary things. Even if unlikely, those things are in the possibility range. We can't rule them out entirely at this point. Now, if we had more time, if you could come take our class, okay, we would work through the whole story of this. And what's fantastic about this story is that dealing with these ethical issues, dealing with taking out insurance against disasters, the way we sit right now, the economic analyses say clearly that wise response to this helps the economy. We end up with more money and more jobs if we deal with this wisely than if we ignore it. And there's a long path that gets there through the social cost of carbon and discount rates and a bunch of other things. But there is a cost which is now not included in the price of fossil fuels, which is borne by society. And that means that there are actions that can be taken that would reduce the cost to society, and that helps the economy. So going for a cleaner environment and consistency with the golden rule and taking national security also happens to be going towards a better economy. And that is the main message of all the scholarship we've done across all of this stuff. And I'll happily chat about that later. Okay? The next question, though, is can we do this? Can we actually get to a sustainable energy system? And the answer is yes. Okay? Let me just show you this. 2,000 calories per person per day. Where does it come from? The reds and oranges up there are where we grow our crops. And the darker it is, the more of the land area is used for crops. So that area up there is what we have changed to feed us by growing crops. Down below is where do we let animals eat grass that we can't eat and turn it into something we can eat. And so everything in color on that plot is what we are using to get 2,000 calories per day. Now suppose that we tried to build with modern technologies a solar farm in a low latitude sunny place that would supply all the energy that the humans now use and a little extra. How much more area would we have to convert to generate human energy use plus a buffer with current technologies? In case you missed it. Now, don't kid anybody. That's one heck of a lot of solar cells. Could we do that this year? No. Could we do it in 30 years? Probably could. And would we ever do that? No. We're going to build it in ways that are convenient to us and closer to where we use it. But just the scaling, I think, is important. Right? And, so yeah, hugely, it's a huge task, but it's possible, right? And I'll say a word about wind. I love this one, right? Before Abe Lincoln is elected president, he's on the stump, and one of the things, he said we need patents, we need inventors, we need learning, we need wind. Wind is an untamed and unharnessed force, and one of the greatest discoveries to be made will be the taming and harnessing of it. If we put a wind farm on the windy parts of the plains and deserts of the world, that is far more energy than humanity now uses. Okay? And we did these TV shows, and you know, these Texas ranchers, they put 5% of their ranch into wind, and it makes money even during a drought. They call it mailbox money. You go out to the mailbox and you get money, thousands of dollars for a wind turbine per year for each one of those. And so even people who don't believe any of this climate change stuff, they believe in wind because it's actually helping them. Okay? So let's run back here. We learned to farm food at a time when we had to. And it has done, with learning, with getting along with each other, some amazing things for us, and has allowed us to increase the population fantastically. We're still hunter-gatherers of energy, and we've done it with trees, and we've done it with whales, and we're doing it with fossil fuels, and we're looking in the Gulf, and we're looking under your backyard, and we're looking, you know, we're the first generation that has shovel-ready pieces that would build a sustainable energy future and that could power everyone on the planet, not just the richest of us, and that could do it for a very, very, very long time. Now, our ancestors took 10,000 years to do this. We can probably do it in 30, 40, 50, something like that, because of all the things that they gave us and all the things that we've learned. And so let me leave you with this picture. I took it in Greenland. It is a rainbow and an iceberg. Can we have a world with a rainbow and an iceberg? Can we have a world in which we protect the integrity of creation? I believe yes. Thank you.
Thank you, Professor Alley. We do have time for some questions from the audience while he's here. Yes.
Yes, Richard Miller from Creighton University. I wanted to just ask you a question about your work on abrupt climate change. So the latest National Academy, as you know, abrupt climate change report, basically, as I understood it, said that the AMOC, the Atlantic Meridional Ocean Circulation, wasn't probably going to shut down until the end of the century. And after that, Steph Ransdorf published a paper saying it's slowing more than we ever expected. Does that now change what the Academy was talking about? Does that now change the issue?
Right, so fascinating question, and thank you. Thank you. So those huge jumps that we saw in the Ice Age that I started up with are linked to sea ice in the North Atlantic. In the modern world, if you go very close to the pole in the north in the winter, not in the summer, but in the winter, the ocean is frozen everywhere except off Norway. And because it's not frozen off Norway, they play soccer on Boxing Day in the UK. So, you know, and why is that? It's because water has two choices when you make it cold in the ocean. It can either sink or it can freeze. And in the modern world, everywhere close to the pole, in the winter, it freezes before it sinks, except in the North Atlantic where it sinks before it freezes. And if the water sinks before it freezes, something has to replace it. And what replaces it is a little water that spins off the Gulf Stream and goes up to Norway and gets cold and sinks, and that heat goes into the... So it never gets below freezing off in Norway in the winter, and that makes Europe a little milder and other sorts of things. But if the water were a little fresher, it would freeze before it sinks. And so there were times in the past that the freshness off of Norway changed, and that in turn changed it from freezing to sinking. And then there's this additional thing that when it quits sinking, the trade winds are still taking water that evaporates from the Caribbean and taking it across to the Panama to the Pacific, and that makes the Caribbean saltier and saltier and saltier, and finally that water goes to Norway and it sinks anyway, and then it gets really hot, and that's those big abrupt changes. And so the concern is that we're hyping the hydrologic cycle and we're melting Greenland and we're freshening the North Atlantic. And by freshening the North Atlantic, we're pushing it towards the freezing direction. And there remains some chance that we will see a jump. What we're fairly confident is that in history, the cooling steps either arrived because there was a giant flood that put fresh water out there one summer and the next winter it froze, or they arrived from overloading the conveyor belt. So you add some fresh water and it slows down, which lets some more fresh water get added, which it slows down, and then it spins down over 100 years. And that's a convective spin down rather than a halocline catastrophe. And so we're cautiously optimistic that the spin down will take 100 years, and by then it's going to be stinking hot for other reasons. So we still think it's unlikely that will jump. But 100 years is still a human lifetime. So we're going to do big things to ocean circulation anyway, but we don't think, in economics, a whole lot of what they do has a 4% discount rate. And translated, that means if it takes more than 30 years, they don't care much. And so the 30-year barrier of modern economic thought, probably nothing huge happens in 30, but it might in 100. And I suspect that you think about 100 and 1,000. Okay. Yeah.
Yeah, my name is Mark Dixon. I'm an independent filmmaker here in Pittsburgh, and I'll be attending the COP conference, the COP climate negotiations in Paris as a citizen observer. And also our mayor, Bill Peduto, will be attending briefly, one of the few mayors in the United States to attend. So we're excited about that. I'm curious to know from your perspective, what should we all be watching for coming out of the December COP agreement for like a collective thumbs up or thumbs down? What are you watching for? What would you recommend we watch for in that negotiation process?
Right. So thank you. We in the United States are signatories to the United Nations Framework Convention on Climate Change, which commits us to avoiding dangerous anthropogenic influence to the climate system. And we are. We have acceded to this. And so we are part of basically everyone in the world who have said we're going to work to avoid dangerous influence to the system. And that in turn gives rise to these very large international meetings where they talk about what we can do to avoid dangerous anthropogenic influence to the system. And it's informed by this body that I was a very, very, very small part of that shared the Nobel Peace Prize with Vice President Gore. And so they are trying to figure out the way forward. And the time from when Bell Labs first invented the solar cell to when it became, financially successful to put it on your roof was decades. And when I was writing the book in 2009 that we turned into the 3-hour PBS miniseries, I could not with a straight face say that solar cells were very competitive in very many places. And in 2015, I can. So it's very clear that we've had this learning curve. I suspect that getting along with each other at a COP is harder than solar cells. So I don't really expect that it's going to cut a deal that will solve the problem. So what I'd be looking for is there serious commitment? Are people moving in a direction that will help? Because I think that once you get moving in a direction that helps, you get some momentum, then other things can happen. And the sort of getting to know each other a little bit, moving forward, I think is really important. And so don't, if it doesn't get everything that's needed, don't panic, because I think they have a learning curve too. And like I say, I suspect theirs is steeper than the technical one. Technical things are just, be perfectly honest. What they did to make this is just blow you away. Einstein's in there. Right? The GPS has relativistic calculations, and if it didn't, it would dump you in the river in a couple of days. But I think that's actually easier than getting along with each other. Yeah?
Robert Sherwood from the School of Business here at Duquesne. What steps should business schools be taking to include or integrate information like this into curriculum.
Right. So if you didn't hear from the back, thank you. What steps should business schools be taking to include information like this in the curriculum? I think the first, you could do it with, one 5-page paper. Just this is real. Okay. Nobody is making up. This is real. And then I suspect, well, for here, I mean, you teach business ethics. And your school is more committed to this than I think the majority are. So I think that's very important. But in terms of the business opportunities, the business framing, so it is the fact that because there is a social cost of carbon, because we are damaging society by burning fossil fuels without including that in the price, and because both the International Monetary Fund and the International Energy Agency have recently looked at this, and they have said fossil fuels are rather heavily subsidized in the U.S. and the world. Directly in parts of the world, indirectly mostly in the U.S. But the recent authoritative international reports say that fossil fuels are notably more subsidized than their alternatives. Right? So this in turn means the economy is distorted through lack of including the full cost of the fuel in the price of the fuel and through subsidies. And in turn, anytime the economy is distorted, that's a business option. That's an alternative. There's profit to be made, which is where this idea that in fact we end up better off by dealing with this than ignoring it. And so I think that if you're teaching the ethics, you teach the technical thing that we can't get around this, and then you add that there really is money on the table at some fundamental level. I've had the remarkable experience of talking to a number of really good economists on this. And the really good economists, I'm not a policy person, I'm not an economist, I am not going to advocate any policy. And the policy that I'm about to tell you is really regressive, so it hurts poor people. So put that in the back of your mind and carry it along. But the economists have said, and this Congressional Budget Office said, if we tax cigarettes, and we do that to raise money for the government and to reduce smoking. And we tax alcohol, and we do that to raise money for the government and reduce drinking. And we tax your paycheck, and we do that to raise money for the government. And any economist will fill in and reduce working. And do this. I've got $10, I need some help with something. I call up a student and I say, give me a hand, I'll give you $10. You say, sure. I say, give me a hand, I'll give you $5 and the government $5. And you say, I'm busy. Right? So by making work less valuable to an individual, they say that we reduce work. So the question was asked, what happens if we tax carbon to raise money for the government and reduce climate change, and we reduce the tax on your paycheck? And the answer is, properly implemented, if everything else I set up here is an evil lie, it doesn't hurt the economy, and it might even help a little bit. Because substituting for carbon is a big deal, and it will distort the economy, and there's no question about it. But substituting for willing workers is also a big deal, and that also distorts the economy. Because this reduces climate change, and that has benefits, the economy ends up better off by dealing with it. And so the economists that I've spoken to across the board, the serious ones have said, you just put a carbon price on and you get out of the way. The first time I ever testified to a subcommittee of the U.S. Senate, it was chaired by a Republican who wanted to put a price on carbon and did not want to see the government making regulations. He wanted the government to have a price signal and get the heck out of the way. And he wanted us to scare the heck out of people about climate change to promote his price on carbon. It was 13 years ago. So I think the fact that economically, you as an individual business have to find a niche or else you can't do a huge amount. But across all the businesses, this is an economic opportunity, not a burden. Yes? Right. So if you couldn't hear on the other side, earning an MBA in sustainability, and congratulations. What do we do personally? Okay. My stock answer right now, I'm not sure the answer. I drove over here. Right. At home, we're trying very hard to live with one car, and my wife drives a car. And so I bicycled over this morning in the pouring rain and got a fleet services car from Penn State. And I have resisted buying a car as some little piece of what I can do. What I generally tell people is first, do the big thing. You vote, you talk to people, take it seriously. And second, pick something, one or two things that work for you, and then do them. And this sort of thing, even if what you do by yourself is not huge, it helps on capacity building. You try to put a bike path in somebody's neighborhood and they yell at you. But you build a bike path in a new neighborhood and everyone wants to live there. And if there's more bicyclists, we'll build more bike paths. So maybe you bicycle. Or maybe you arrange recycling. Or maybe, you find something that you do that contributes to people seeing it, that contributes to capacity building. The first people who put solar cells on their roofs were on the bleeding edge. But now it's the leading edge because companies learned how to do it. And once they learned how to do it, they fixed the problems, and now more and more. There are places in the world you call up and get your shingles, and they say, do you want the solar cells with that? State College isn't totally at the top of that yet, although there are people, good people, trying to do it. So helping people build capacity by picking something and doing it that works for you, and then doing the overarching thing of voting and talking. That's my answer.
One last question.
Yes? Yeah, no, I do not know of any practical, if you didn't hear, the question was, are there any practical obstacles to getting to 100% renewables? I don't believe so. There is a question of storage, for example. In the very short term, there's a recent paper that says storage will actually help coal, but long term, suppose for the sake of argument that a lot of us bought plug-in hybrids. Okay? And we have a lot of bright electrical engineers who upgrade the grid over the next 30 to 50 years. And you've got a little biodiesel on your plug-in hybrid, and you've got a battery. And you plug it in, and when electricity is cheap, they fill up your battery. And when they need a little, they buy it from you. And you're now, it's like the internet. You can be a buyer, but you can be a seller. You can work it both ways. And one estimate was that 3% of the vehicles doing that would allow you to blow past 50% renewables with no problem. And, if you increase the numbers, there's a lot of storage in a lot of batteries. And so over the 5-10-year range, if we wanted to do crash course, if we said we have to stop before 2 Celsius, we're so close to having committed to 2 Celsius that everything is on the table. And you're worrying about methane, and you're worrying about black carbon, and you're worrying about trying to build more nuclear, and you're worrying about everything because we're so close to hitting the 2 Celsius already. If you said, look, we're going to try to keep it below 3 or something like that, no serious problems that I see. There are rare earth elements that go into the magnets in the wind turbines. But the truth is they use rare earth elements in cracking gasoline in oil refineries too. And so rare earth elements have been short recently, in part because China was producing a huge amount at a low price, and supplies from elsewhere got low, and then China reduced the exports thereof. The geologists to whom I've spoken said that if you got the geologists serious, they will find more. I worry long-term a little bit about phosphorus for fertilizer, but that's not one that really worries me that much. So I see no serious barriers to moving to 100% renewables on the timescales that the economists like.
Well, thanks everyone. That's a wonderful lecture, a great start to our 3-day conference through Friday noon. I have a couple of really important announcements for you. First of all, this is all live streaming, so it's going out globally. So that's a really nice thing for us to educate across the world. Secondly, could Bob Struth stand up, please? We have worked very hard through Bob's genius in the School of Business to calculate the carbon cost of this conference, carbon offset total and carbon free. Thanks, Bob, for doing that for us. One last group to thank. That is the future stewards of this creation, the students. Thank you very much for coming tonight. Inspire us with your leadership. And we have a little reception in this room as you leave, so please join us all. Thank you, everyone. Thank you, Richard.